In lesson 12.4, we're going to look at angle measures and segment lengths as they relate to circles. Now, if you remember in lesson 12.3, we talked about what happens when we have an angle measure that's vertexes on the circle. It was half the length of the arc it opened up to. Well, now we're going to look at angle measures as they are inside the circle, but they're not a central angle, and then when they're outside the circle. So let's take a look at Theorem 12.3. The measures of an angle formed by two lines that intersect inside a circle, okay, which is not going to be the central angle, is half the sum of the measures in the intercepted arcs. Now, this is angle 1. In order to find angle 1, you're going to take half of the sum of the two values, which would be x and y. These are the two arcs that our angle intercepts. So now this angle 1 here, we know these are both vertical angles here, so these two angles are congruent, but the arcs they open up to could be very different because of where they're related to in the circle. So that's why we take the sum of these two and then divide it by 2. Now, if the angle is formed outside the circle, so if our two lines meet out here, then the measure of an angle formed by two lines that intersect outside a circle is half of the difference of the measures of the intercepted arcs. So we've got three situations here that kind of describe what we've got. We've got a secant, two secants, or two chords, and this angle intercepts this arc here, and it opens up to this arc here. So we take the larger, which is always going to be the one furthest away from our angle, minus the smaller, and then divide by 2. So same with the second one. This is made by a tangent. This line right here on the top is tangent. So the point of tangent C is going to be the point where the x and the y meet right here. So this is going to be the difference of this arc minus this arc divided by 2. And here we have two tangent lines that intersect the circle, so this is going to be from here to here is the x degrees minus this arc here divided by 2. Now, a term that I kind of mentioned a second ago was a secant. A secant is a line that intersects a circle at 2 points. So a chord is part of a secant. So line AB is a secant. We have a secant ray. We could also have a secant segment here. And a chord is part of a secant. So let's take a look at our first example. And in this one, we're trying to find the value of x, the angle that's in between. So what we have to do first is we're going to take a look at our two arcs that it opens up to. So this angle right here opens up to 90 degrees, and because they're vertical angles, this would be x as well. It opens up to 46. So to find the measure of x, we're going to take the 1/2 times the sum of 90 plus 46. So we add these two together, it gives us 136, and then we take half of it, and x is going to be then equal to 68 degrees. So let's take a look at one that's where it's outside. The angle is formed outside, it's 20 degrees. Now this one's a little different. We're not looking for the angle, we're looking for the missing arc. But the same formula will apply where we're going to take the larger arc minus the smaller arc times 1/2 is equal to 20. So 20 over here is the angle. It's on the outside over here, so 20 degrees is equal to 1/2 of 95 minus angle Z. So first thing I'm going to do is get rid of the half. We do that by multiplying both sides by 2. That cancels over here. Multiply this side by 2 and we get 40. So now 40 is equal to 95 minus Z. Next thing we do is subtract 95. Now notice that gives us a negative number here as we subtract it, which is fine because this becomes a negative 55, but it's equal to a negative Z. So we just have to change our sign or divide by a negative 1. And so Z is equal to a positive 55. All right, so Now let's go to the next few examples. All right, you guys try these three. I'll stop it, and when you come back, check your work to see if you got it right. Okay, so what I've done is I've set each one of these up so we can see, first of all, if you set it up correctly. Now there's two ways to work this first one here. This one is set up of two tangents, which means this arc starts from here, 110 goes from here to here, and W goes from here to here. So if we set up our equation, 70 is our angle on the outside, so we're going to do the difference in the arcs. So because our variable is over here inside the parentheses, I want to first get rid of my 1/2 by multiplying by 2. So multiply both sides by 2, cancels our half, and we get 140 is equal to W minus 110. Add your 110, and that gives us 250 degrees is equal to W. Now one other way to look at this problem was that if you know a circle is 360 degrees, and this is 110, this is the rest of the circle. So you could have done 360 minus 110, and that would have also given us 250 degrees. So always look for those shortcuts. I know we tend to go with the equation every time, but there are other ways to solve these problems. Now this one here, the angle is formed on the outside. That means we're going to take the difference of the two arcs and divide by 2. So here we have the larger arc is 110. We're going to subtract 110 from 110 minus 30, which is going to give us 80, and half of 80 will give us 40. So y is equal to 40 degrees. So this is a 40-degree angle on the outside. Now this angle is formed from inside the circle, two chords intersecting. So that means that we're going to do the sum of the two arcs that it opens up to. So we have 35 is equal to 1/2 x plus 30. Once again, we get rid of the half by multiplying by 2. Cancels our 2. This gives us 70 is equal to x plus 30. Subtract your 30. And 40 is equal to x. Hopefully you did pretty well on those. So now let's take a look at a word problem. A satellite in a geostationary orbit above Earth's equator has a viewing angle of the Earth formed by the two tangents to the equator. The viewing angle is about 17.5 degrees. So this is the satellite out here. It views the Earth. It can see from this point to this point. Now what is the measure of the arc that the Earth is viewed from the satellite? So what we're looking for is we're trying to find the measure of this arc right here. We want to know how much can this satellite see all the way around the front part of this right here. So they don't give us anything but 17.5 degrees. So we're going to call this part x. That is what we're looking for. So now we got to come up with an expression to write for arc AEB. Now the angle is formed outside, so we're going to take the difference of these two arcs. But in order to write this equation, we have to relate it to our x value here. So let me kind of give you an example here. If we said that this was 100 degrees, then how would we find the rest of this circle? Because it goes from here to here is 100. This is the rest of the circle. Well, what you do is you would take 360. This side would be 360 minus the 100. And that would give us the 260. So that's the operation you do. So now what we're going to do is we're going to take and relate this to x. So we'll do the same thing. We're going to say this is going to be 360 minus x. So that is the value of this arc. So we set up our equation. The angle on the outside is 17.5 equal to 1/2 of the larger arc. That would be the, and I'll put this first. This is going to be the 360 minus x. And then we're going to subtract the other one, which will be the x here. So we're subtracting these two here. So this gives us 360 minus x, which becomes 360 minus 2x. Now you have two options. At this point here, we have a half that we could either distribute through here because they're both even, or you can multiply both sides by 2 and then bring the 360 over and then divide by -2. Either way works. Since we've been doing the 1/2, I'm going to continue doing that. I'm going to get rid of the 1/2 by multiplying both sides by 2. 17.5 times 2 will give us 35 degrees. 35 is equal to the 360 minus 2x. So now the next step is to subtract 360. That's going to give us a negative 325 and set it equal to a negative 2x. Divide by -2, divide by -2, and that tells us that x is equal to a positive 162.5. That means that the amount of degrees that the arc covers that this satellite can view is 162.5 degrees of the Earth out of the total 360. All right, now let's take a look at let's move over to segments. For a given point in the circle, the product of the length of the two segments from the point to the circles is constant along any line through the point in the circle. So we're going to have three different cases here. The first case is where we have two chords that intersect inside the circle. Case 2 is where we have two secants that intersect. And they meet outside a circle and they go through the circle. And so their point of intersection is outside the circle. And then we have the third one is where we have a tangent and a secant that intersects outside the circle. And so the formulas are this. It is the segment length of A times the segment length of B. So what it is, this line right here has been cut up into two segments, wherever its intersection point is. This segment times this segment is equal to this segment times this segment. So A times B is equal to C times D. In case 2, it is the outside length, W, times the entire length of the line. Okay, so it's the outside length times the entire length equals the outside length times the entire length of this line. So Y times Y plus Z. That's why it's Y plus Z, is because that is the length of the entire line. You add the Z length plus the Y length to get the full length here. So it's the outside part times the entire length, outside of W, this top line times the entire length. Now, in case 3, because we have a tangent, this line doesn't go inside the circle. It stops right here at the point of tangency. But the same equation can apply. The outside length times the entire length, which means it's going to be t times itself, which is t squared. The outside length here is y times the entire length, which is z plus y, or y plus z. And so that's just like we did in case 2. So let me give you a general way to write this out. Okay, so in case 2 and case 3, it is the outside length times the entire length. Equal to the outside length of the other line times the entire length of the other line. So make sure you have this down. This is just a general form. It kind of summarizes what we're doing here. It makes it a little bit easier to understand. The outside length times the entire length equals outside times the entire. So let's go do a couple examples. Find the value of the variable in circle n. Well, this is a two secants that intersect outside the circle. So we're going to take the outside length, which is going to be 6, times the entire length, which is 6 plus 8. Now you don't have to write the 6 plus 8 every time, write what you're adding here. For this time I'm just showing you that this is what we're adding to get this number. This is equal to 7, the outside length, times the entire length, which is going to be y plus 7. So we add these two together. This length is 7, this is y, add them together. So 6 and 8 gives us 14, multiplied by 6. Okay, this one we have to distribute, so we get 7y plus 49. Now, 6 times 14 is 84, equal to 7y plus 49. Now we're just left solving the equation. So subtract 49. 7y is equal to the difference of 84 minus 49, which is going to be 35. Divide by 7, and y is equal to 5. Okay, let's look at another one. This one we have formed by a tangent and a secant. So we take the outside length, z, times the entire length, which is also z, equal to the outside length of 8 times the entire length of 8 plus 16. Z times z is z squared. And this becomes 8 plus 16, which is going to be 24. And 8 times 24 is 192, equal to z squared. To undo the z squared, we're going to take the square root. So z is equal to the square root of 192. And so we're going to round to the nearest tenth, which is going to be approximately 13.9. So z is approximately 13.9. All right, let's take a look at these two right here. You guys work these two. So pause the video, come back and check your work. Okay, so let's make sure you set this up correctly. It's the outside length 14 times the total length of 14 plus 20 is equal to the outside length of 16 times the entire length of 16 plus x, or x plus 16. So I combine these to get 34. 14 times 34 is 476. Distribute the 16, so we get 16x plus 256. So bring this 256 over, subtract to get 220 equals 16x. Divide by 16, and that comes out to be 13.75, which rounds to be 13.8. Now this one here, we have two chords intersect inside the circle at this point right here. So it's going to be the length of this segment times this segment equal to this segment times this segment. So 6.5 times m is equal to 3 times 7. So we get 6.5m equals 21. Divide by 6.5, and m is equal to 3.2. So this concludes lesson 12.4.